Here we go. Hi everyone, we're the Alexa Modular Adapter team. I'm Anon.
Chris. I'm Kenneth. So the client for our project is Amazon. And given its size, Amazon has a lot of fingers in many different enterprises. But most importantly for our project, it's its investment in the virtual assistant Alexa and the smart home devices it's located on. And one of the teams that actually works on this technology is the Alexa for Everyone team. And the Alexa for Everyone team's main goal is to make the Alexa platform and the Echo devices it's located on as accessible to as many people with disabilities as otherwise they wouldn't be able to use this technology. And one of the features that they actually worked on to achieve this goal is, if you look on the bottom left of the screen, there's a Echo device or called a Echo Show, where instead of having a user having to say the command, "Hey Alexa, do this action," on there are specific actions for the Alexa to do instead of having the user to say it. So with a team with this kind of technological background, the project that they assigned to us had a lot to do with the Alexa platform. And that project was the Alexa modular adapter. And the basic way of explaining this is, it's basically a voice interface between some kind of switch enabled device like a fan with an off and on button, for instance, and the actual client, where on this modular adapter you would connect a switch enabled fan like with an off and on button as previously said, and then you would be able to communicate to this modular adapter to turn the fan on and off by saying, "Hey Alexa, turn on the fan," or "Hey Alexa, turn off the fan." And then the modular adapter would switch the state of the plugged in switch enabled device. And another goal that our liaison wanted us to accomplish was to make the setup of the modular adapter as easy and painless as possible, especially with setting up the Wi-Fi. And in order to actually get this prototype up and running, we actually had to figure out what switch-enabled devices we would get the prototype to actually work on, especially ones that would have a really positive impact on the disabled community. And after much research, the two devices that we decided on was the switch-adapted toy and the motorized standing desk. For the switch-adapted toy, it's basically a little Einstein toy with a audio jack that comes out of it, where you can connect it with a button. And on that button, you can press what kind of song you want. So one press is the first song, two presses on is the second song, and this goes on for some 4 songs. Our liaison partially recommended us to do this as our first device, as a good way to start off getting the modular adapter to work with a switch-enabled device. And for the other one, we have the motorized standing desk. And this is basically a substitute of a hospital overbed table, which is a table you would see in obviously hospitals or old age homes for people who are bedridden, who can't really get out of their bed. And instead of eating or working on their lap, they have a table that goes over it to solve that problem. And on this specific motorized desk, if you look on the far right of the screen, you see 2 up and down arrows that obviously sets the specific height of the standing table. And the 1, 2, 3, and 4 buttons are basically memory buttons. They're a way for a user to basically set a predefined height and have the motorized table to go directly there without actually explicitly doing it. An example would be switching channels on your radio, if anyone still has one. And a way that this motorized table is actually connected to the Pi is through an RJ485 Ethernet cable, which will be discussed later.
So there are 2 viable options to get the result that we want. The first one is through the Alexa Skills Kit, and the second one is through the Smart Home for AVS, or Alexa Voice Service. For the Alexa Skills Kit, similar to one that the other Alexa team did, basically have to build skills from scratch, making it very customizable. However, the skills have to be hosted in a cloud or a server. As for the Smart Home for AVS, it comes with 4 pre-built capabilities to control the power, mode, range, and toggle. With this method, developers don't have to host those capabilities in the cloud or server, making it cheaper and easier to maintain in the long run. And for those reasons, we opt to go with the Smart Home for AVS. And let's take a look at the demo.
Alexa, set toy to first song. Alexa, set toy to another song. Alexa, set table to 4. Alexa, set table to 6.
And as you may have seen in the demonstration, there are a lot of hardware involved in this project, but I'd like to point out this particular piece of hardware, which is the Raspberry Pi. And the reason we chose Raspberry Pi is because it has the general purpose input-output pins, making it very versatile. We extended the pins with a breadboard and relay switches to control our devices.
So let's take a quick look at what's really going on here. So we have the user on the left speaking into an external microphone connected to our Raspberry Pi. And then using the Alexa Cloud, we can make of what the user is saying and send back an action for the connected device on the right to perform. To give a more detailed description, we start over here on the left with voice commands. And this is where the user can say, hey, Alexa, turn on my toy. And then that will be captured by an audio mic. And from there, we can go to our AVS handlers. And what AVS essentially does is it has a user voice command sent up to the Alexa Cloud. The Alexa Cloud will make of what the user is saying and send back a device ID, which is whether the device is the table or the toy, and an intent. So intent is essentially an action that the device needs to perform. So we go up to Alexa Cloud, we know what the user is saying, we send back an intent. And from there, our smart home handlers can make up what's going on. So we mentioned earlier that we had power, range, mode, and toggle. And we use those capabilities on the right here with our general purpose pins. So on the farmost right, we have our table and toy connected through an RJ45 or Ethernet connection, and our toy is connected through an audio jack. But to support both of those, you need to extend those ports through our general purpose pins. So we have an RJ45 breakout and an audio jack breakout. So then using those general purpose pins, we can toggle specific pins in order to control both devices on the end here.
So one of the features that our liaison from Amazon let us know is what is to think about when we're setting up the modular adapter, how do we make the setup as easy and painless as possible? And for us was, how do we get it to actually connect with the internet, especially when we're giving it to customers who may not have the necessary motor functions to actually go on the adapter, click on what specific Wi-Fi network they want to join, and press in what the specific password is. So after much work, we actually looked at what would be the best solution. What we found was using an offline voice agent. And basically this would make it so easy for the user to just simply go to the modular adapter and have the modular adapter actually connect to the Wi-Fi by just using the user's voice, which is also used on getting the Alexa to work with the AVS. And in order to actually get this working, we use the Mozilla's speech-to-text engine called Deep Speech. And in order to actually demonstrate how this technology works, basically a user will go to the modular adapter, ask it for available Wi-Fi networks, and then from those available Wi-Fi networks, a user would pick one of those Wi-Fi networks, spell out the password, and then the modular adapter would actually take the Wi-Fi network and the spelled out password and connect it to some Wi-Fi network if it's available.
So at Amazon, instead of settling for minimum viable product, they thrive for a minimum lovable product, and that is something we learn from them. So in the end, our device can be set up by voice. It supports multiple pluggable interfaces, and those connected devices can be controlled by voice through Alexa. So what are some of the improvements that we can do to the adapter? First off, we can improve the offline voice agent so that the setup process can be smoother. And second, we can expand to support more pluggable interfaces such as USBs. And lastly, we can try and support IRF control devices similar to something the other Alexa team is doing. So the main takeaways from working with this project is that voice assistant has so much potential, but we just don't see enough products out there to that serves the disabled community. And our product serves as the proof of concept for this. And secondly, we learned to weigh the pros and cons between different implementations, and we picked the right one that worked out for our project, which is the smart home for AVS option that we mentioned earlier. We'd like to thank a few people who've made this project possible. First off, David Ferrix and the Alexa for Everyone team, instructor Richard Julik, Professor Patrick Manti, and the TA Rindam Sarma. And lastly, we'd like to thank Brian and Kagan, our former teammates who couldn't continue to work on the project due to the pandemic. And that is for Alexa Modular Adapter. If you guys have any questions, see us at the poster session. Thank you.
All right, thank you, Tim.